Quadratic function graphs, well, we already know that y equals x squared is this. And if you have y equals x squared plus 1, the graph shifts up by 1. And if you have y equals x plus 1 squared, that shifts left by 1, right? And another thing that we learned was that if you have y equals to negative x squared, the graph opens downward like this. Okay? And in this case, we call this concave down because the graph is bent downwards. This one is concave up because the graph is bent upwards. Okay? So this one's called concave up. And if you have y equals negative x squared, you can do the same kind of shifting as before. You can do y equals to negative x squared plus 1, which will bring the graph up like this. And if you did y equals to negative x squared, x plus 1 squared, then the graph will move left by 1 like that. Okay? And on top of that, what about y equals to 2x squared? What does this do? Well, this 2 takes the graph, and it's like you stretch it twice in the y direction, and that will make the graph thinner, right? So you have the graph that's thinner than what you have there. And if you had in the opposite way, it's like 1/2 x squared, that would make the graph wider, slightly wider than before. Okay? Now, if you took any of those graphs and did shifting, the graph you're going to get will be the following. So if we take any kind of graph y equals to ax squared, where a could be like 2 or 1/2 or negative 1/2 or whatever, then if you move h to the right and k to the up, this is what happens. You have y equals to a times x minus h squared plus k. You move h to the right, k up. Now, what does this do? It does the following. Originally, let's say y equal to ax squared is like this. Then I'm assuming the a is positive. Then you're moving h to the right and k up so that the new graph will be like this. So this hk really explains where the vertex would be. See, in any parabola, there's this distinguished point where there's the turning point, and that turning point is called the vertex. This is called the vertex. And whenever you're given the formula in this form, because this is a form that easily tells you where the vertex is, it's called the vertex form. So let me write down vertex form. This is y equals to a times x minus h squared plus k. And in this case, the vertex would always be h comma k. Now, to actually get a taste of what that is, let's try to draw a graph that has values like that. So what if you had y equals to, say, 2 times x minus 1 squared plus 3? Okay. Then you know that the vertex is 1, 3. And before any translation, this was y equals to 2x squared. So it's kind of like a narrow parabola. So here's what we have. We have 1, 1, 2, 3. Here's the vertex. And it's some kind of a parabola that's kind of narrow. But to really figure out the graph, a better thing to do is to find the intercepts. There's the x-intercept and the y-intercept. This graph, by the way, doesn't pass through the x-intercept. It doesn't pass through the x-axis, so it doesn't have an x-intercept. It only has y-intercept. How do you find the y-intercept? You plug in 0, right? To get the y-intercept, you you set x equal to 0, so y is equal to 2 times 0 minus 1 squared plus 3. Negative 1 squared is positive 1. 1 times 2 is 2. 2 plus 3 is 5. So you have this 5 here, and that is the problem. Okay, that's how you draw the graph.